Hi, Charis.
Hi,
How are you?
good.
Good. Okay. So let's go ahead. Whenever someone asks you how are you, you must also ask, I'm good. Thanks for asking. And how about you? That is the formal way. Got
Okay.
it?
Okay.
Yeah. How are you?
I'm good. Thank you. How are you?
Me too. Thanks for asking. All right. So, last time we were discussing science, right?
Yes.
Since we have less time today, we'll be having an hour class. Let me know, like, you would like to go with science or English, because English will involve some certain exercises too. Or you would
Any
like to continue with science?
sign?
Okay, so let's go because the topic was not completed. I gave you some questions in homework. Did you work on that?
Yes.
Yeah, please let me help with the answers. Or
Gold
you may
is a
tell.
conductor. The fastest conductor is silver.
Mm-hmm,
Explain metal and non-metal in detail. Metal is shiny and conductor of heat electricity, and it's on the left and center of the periodic table.
mm-hmm,
While non-metal is on the upper right of the periodic table.
right. Some other questions were given to you?
I don't think so.
How many questions were given to you?
Oh, I forgot to do one.
Which one?
Are star larger than sun?
Hmm. You may work on these questions later.
Okay.
Okay, so we were talking about these things. Let us revise first. Let me ask you. So, what are these five states of matter? Can you name them?
Solid, liquid, gas, plasma, and
And you're going to cheat.
one Einstein constancy.
Bose, Einstein, condensate.
Was Einstein condensate.
So can you tell me something about plasma?
It's very hot. Um,
Extremely hot, hmm,
extremely hot.
state of matter. Okay. Examples?
Lightning,
Hmm.
and the atom are very wide apart.
Very good. And what about the properties of Bose, Einstein, condensate?
It's super coated.
Super
The
cooled. Hmm? Extremely cooled.
mhm.
Yeah.
The atom are together, stuck together.
Right. So we were talking about these states. Plasma we talked, and one of the thing I also told, like plasma, you may also get chance to study in biology, like blood plasma, right? Did I tell
Mm-hmm.
that or not?
Yes.
Okay. So plasma like gases have an infinite shape and have an indefinite volume. We have talked of comets even. You have not researched over comets
Mhm.
that is
Oh,
found in space.
not
Comets.
yet. Not yet.
Comets. Okay. So here we see the particles. The negatively charged electrons, yellow, are freely streaming through the positively charged ions, blue. Can you
Okay.
see the picture?
Yes.
So negatively charged electrons, they are in yellow, and positively charged ions that you see in blue, they are freely moving in plasma, right?
Mm-hmm.
Okay. And here you see like some examples I told. So this can be something like you see solar wind, you see nebula. Nebula, nebula.
No.
Oh, you do not know nebula. That is an interesting thing. Okay, so write it down. Just let me explain to you what nebula is. Okay,
Okay.
right. A nebula is a vast cloud
First cloud,
of
cloud of
interstellar dust. Interstellar dust.
inter.
Interstellar.
Uh-huh.
Dust and gas.
Does and gas.
Right in bracket, mostly hydrogen and helium.
Mostly,
Hydrogen and helium.
yeah.
In space.
Yes. Okay.
Um, comma, acting
Um,
as acting as
up to us.
stellar, Stellar,
Stellar. Stellar.
nurseries, Nurseries, nurseries,
Yes.
where
Where new star
new stars form or new stars form or
or
as remnants of as remnants of
of
remnants remnants
are uh-huh,
yeah, of
of
dying stars.
dinosaur stuff. Okay.
You heard about supernova fusion?
Um, yes,
What
but
is the yeah
not in science
yeah so where did you hear about it?
in the game.
So what does it do?
Um, not sure.
Like planetary nebula or supernova debris, we call it. In planetary nebula or supernova debris. Debris, like garbage in the space. Supernova debris. These cosmic clouds are often beautiful. Supernova debris or planetary nebula, these are just dust and particles in stellar dust or gases, mostly found in the form of hydrogen and helium. They are found in the space. Okay, and they
Mhm.
look beautiful. Okay, let me just show you, then you'll be better understand. Let's go on Chrome and just check it. You will be able to grasp them easily. This shows, you know, the beautiful world in space. I'll show you some pictures. Can you see these pictures?
Yes.
Yes. Helix Nebula, white dwarf may have destroyed planet. This. These are the things like dust particles mm, uh, found in the form of helium or hydrogen. So these. Do you see these?
Mm-hmm.
Aren't they beautiful?
Yes.
So these are the things which we discuss in nebula. Um, there is a site named nebula.tv. Okay.
Mm-hmm.
So this is you were talking about, I guess this is related to fiction or something, but we are talking of really like what exactly is nebula. So a nebula is A giant cloud of dust and gas in space in general way. Nebula is this thing, you can also write if you want. This is generalized format. Nebula is what? A giant cloud of dust and gas in space, right?
Mm-hmm.
So some nebulae, more than one nebulae, uh, come from the gas and dust thrown out by the explosion of dying star. So when there is explosion of dying star, so um, some nebulae or more than one nebula come from the gas and dust thrown out by the explosion, such as supernova. Then we call it supernova. It means when a star dies, what happens? Understand? When a star dies, with the explosion of dying stars, nebulae or more than one nebula comes out of it, such as supernova effect. We know other nebulae are regions where new stars are beginning to form. For this reason, some nebulae are called star nurseries. I told you like nebulas are star nurseries as well because when a star dies, you understand how a star dies? E-
Um,
Exploding. Explosion, you understand?
he maybe
Okay.
not sure.
You need to learn a lot. These are beautiful things. Supernova. Let's see. Go ahead. Look this. Here. A supernova is a powerful luminous stellar explosion marking the dramatic death of a star. This you can write because this is something you may remember as definition. A supernova is powerful luminous stellar explosion marking the dramatic death of a star. Done?
Not yet.
So this is about explosion of a star. When a star dies, then some kind of dust particles in the form of helium, hydrogen spreads away. So that we call supernova or supernova effect. A supernova is a powerful luminous stellar explosion marking the dramatic death of a star. Written?
Yes.
Yes. So let's explore more about it. I want you to put yourself in research as well about supernova because this is an interesting topic. Okay. This is really an interesting topic. You will definitely love it because most important thing, as I told, it looks so beautiful when you see the pictures. Huh? And interestingly, um, many stories people create around, they say the legends in like in India, it is quite famous. People say when a star, you see a star falling, you may ask for a wish. They believe in
Oh,
that thing. Is, is that prevailing in your country too?
he
No?
no.
Yeah. So,
When I read book about it, it is
which book did you read about it?
like comic.
Comet. Okay. What was in that?
Like if you see a sapphire, you have to make a wish or something.
Okay. So, look, there are some stuffs which you may go through. Like imagine the universe. This is wonderful thing. You keep on visiting this site that is NASA site. Do you know NASA site? NASA.gov.
I know NASA, but
Kindly
I don't think
put
so.
it as a note. This site nasa.gov. Keep on surfing this site. You will find amazing facts about space and science.
NASA dot what?
Gov.gov.
Okay.
You may explore this site. For now, you may read this with me. That is about animation of a supernova explosion ending in a pulsing neutron star. Where are you?
Hmm?
Where are you? Your camera is off.
Oh,
Are you getting bored?
No.
If you get bored, just let me. I will just drop this topic because I just wanted to go in depth so you may understand each and everything. So this is supernova. You may read this.
A supernova is
The plural of supernova is supernovae.
the plural of super is supernovae, the explosion of a star. They are extremely important for understanding our galaxy. They heat up the interstellar medium, distribute heavy element throughout the galaxy, and accelerate
Accelerate, not accelerate. Accelerate cosmic rays.
accelerate cosmic ray. But what caused a star to explode? And there more than one type of supernova?
Yeah. So first thing
Um,
we wait. First thing we understood, it means supernova is what? In general, what is supernova?
um, explosion of a star.
It means dying of a star, and when it explodes, that creates supernova effect, right?
Yes.
Very good. Yeah, indeed. Go ahead.
Indeed, there seem to be two distinct type of supernovae. These
Supernovae.
supernovae, these which occur for a single massive star, and those which occur because of mass transfer onto a white dwarf in a binary system. As who you will see. However, it is only what gets the process start toward the explosion which
Differs.
differ between the two types.
And here are those supernovae from single massive stars. I told you an interesting fact earlier that there are stars that was also part of questions which are larger than sun. Do you remember that? In last class we discussed this. There are stars, and that was the question I gave you. Are the stars larger than sun? I gave you that question or not?
Yes.
Yes. So here you will find the answer as well. There are actually stars which are 8 times larger, massive than sun. Do you see this?
Yes.
So we know these facts, but you know how it works actually. If stars are larger than sun, massive than sun, then how come we see sun as bigger than stars? Can you guess?
Because it's more closer to us.
Yes. I have a question to you.
Yes.
Why in between the class you keep on playing with your hair?
I don't know.
Just focus on the things, okay? So, stars which are 8 times or more massive than sun and their lives in a most spectacular way, okay? They go supernova. What do you understand here? Stars
Which are 8 times or mass
or more massive, 8 times or more massive than sun
sun in their life
in most spectacular way.
way,
Yeah. Do you understand what does this word spectacular mean?
like special way.
Yeah.
Like
Spectacular mean very impressive to see, right? A special way, okay. So they end their life. It means they die in very spectacular way, in kind of appealing way. When we'll see like those pictures I just showed, I have demonstrated you. You have seen those were beautiful, right?
yes.
So this actually happens there in the space. So, a supernova explosion will occur when there is no longer enough fuel for the fusion process in the core of the star to create an outward pressure which combats the inward gravitational pull of the star's great mass. So, here a reason is mentioned why supernova explosion will occur. Read this.
Because a supernova explosion will occur when there is no longer enough fuel for
Yeah,
the fusion process in the core of the star to create an outward pressure which combat the inward gravitational pull of a star's great mass.
right. Did you understand this?
Yes.
What did you understand out of it?
A supernova explosion will occur when there's not enough fuel for the fusion procession in the star core.
Okay. When there is no fusion process in the star's core, do you know like every star is having gravitational pull inside?
No.
That is also a fact. Like every star is having gravitational pull in the star, pull inside. Like here we see like this is also mentioned. Supernova explosion will occur when there is no longer enough fuel for the fusion process in the core of the star to create an outward pressure which combats the inward gravitational pull. Do you see that? Which
Yes.
combats the inward gravitational pull.
Gravitational
It means
pull.
there was inward gravitational pull of the star's great mass. First, the star will swell into a red supergiant, at least on the outside. What would be the first step we'll be seeing when a star would be dying? The first thing which will be noticed that is
On the outside,
on the outside. What would happen?
it will
Star,
swirl into a red giant.
yeah, red supergiant, and then go ahead, keep on reading.
On the inside,
On the inside, what would happen?
the core yield to gravity and begin shrinking. As it shrinks, it grows hotter and denser. A new series of nuclear reactions begin to occur, temporarily halting the collapse of the core, but
Alas,
alas, it is only temporary when the core contains
essentially,
essentially just iron when
it has nothing.
it has nothing to fuse because of iron's nuclear structure.
Mm,
Fusing iron does not result in a net yield of energy since energy produced cannot be maintained. The star begins to collapse.
mhm.
Fusion in the core sees less than a second. Star begin the final phase of gravitational co- collapse. The core rise over
Core
100
temperature
core temperature rise
rises.
over 100 billion degree as the iron atom are crushed together.
Okay, now wait. So what does it say? The core temperature rises to how much?
100 billion degrees.
Isn't that much, extremely heat?
Yes.
So what would we call it? Which state of matter?
Plasma.
Yeah, so that's how plasma is discovered when scientists notice that there are some of the things in space which are extremely heated. So they named it fourth matter. Earlier, when they were doing kind of research, they only found three states of matter. Those we call like main state of matter. But then this happened, like they noticed that something extremely heated can be found in space, like in the form of
Is
supernova stars, right?
is lava like plasma or
Can
something?
say that. You can consider that, but these are more in temperature than lava. Okay, you'll
Okay.
find an interesting fact like sun. Do you know what is the temperature of sun? Was it measured?
I'm not sure.
Actually, it was not exactly measured, but that is just like temperature of what is temperature of sun. It was not exactly measured, but there is a solar probe. Do you know solar probe has been sent to monitor sun or to just observe sun? Do you know that? Solar
No.
probe? There is a lot to learn. So, what is the temperature of sun? The estimated value it is showing. The temperature of the sun varies dramatically by layer. ranging from approximately 15 million degrees Celsius, 27 million degree Fahrenheit in its core, to relatively cooler 5,500 degrees Celsius, that is 10,000 Fahrenheit at its surface. So there are two things we see, like core. This is the hottest part when nuclear fusion, fusing hydrogen into helium, occurs, generating all the sun's energy. And the core is where everything is. What would happen to you if you reach in that temperature?
You will
Suppose
die.
you will die, you will disappeared. So this is something amazing, but this is just 15 degree Celsius, and what we have seen in super case of supernova, how much? How much? Once again, 100
100
billion
billion.
degrees. Do you understand what kind of extremely heated up this is?
Yes.
The temperature reaches 100 billion degrees. Oh my God. Can we ever actually trace that data? Can our solar panels or whatever, like our I told you about satellite yesterday. Can any satellite, can anything be that much powerful that can combat this temperature? Do you think so?
No.
No. Still science could not make something which can directly observe sun even. I'm not talking about stars. They are, of course, more massive. Some of the stars are 8 times massive than sun, and some of them are more massive, like more than 8 times. You read that today, right?
Mm-hmm.
Yeah. So, and one interesting fact about sun you have just noticed here, like 15 million degree Celsius, that is 27 million degree Fahrenheit in its core. It means that is the temperature. But when we are talking about its core, you understand core?
Yes.
What is core?
Core is like the middle inside part of a
Yes,
planet.
yes. Okay. So wait, let me just go through the picture. Yes, here. So this thing. This is the picture. This is we will say center, the nucleus, and the core is outer layer, right?
Mm-hmm.
So the core is not that much heated, but like this picture shows very well. This one, mm, how hot is sun? Okay, so we found like we just discussed right now, core is not mm, that much heated. Like that is cooler than the you know the area which it has like 15 million degrees Celsius in its core, but relatively cooler on its surface, core and surface. So in the nucleus and on the surface, that is a different thing. So we will find like center or core. This is the core, like we see this 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 is the layer. You can see the picture of layer.
Mm-hmm.
Yes. So this is what this is core or center, right?
Yes.
Core is what 15
Fif-
million degrees Celsius. Yeah.
uh-huh.
This is what we discussed here. 15 million degrees Celsius, right?
Yes.
Yep. And when we are talking of the other layers, there are other layers as well. Do you see the second layer, the yellow one?
Yeah.
This is called a radiative zone.
Red.
Better you may
Radioactive.
take a snapshot of it and you may just revise it later.
Okay then.
Yeah. So this is called radiative zone, and this is how many millions degrees Celsius?
Um, 7 million
Yes.
Celsius.
Yeah, 7 million degrees Celsius. And this one is what? This is read what is this? This which zone is it? Read this one.
Convective zone.
Con convective zone. And this is how much?
2 million Celsius.
Yeah, 2 million. It is saying in Kelvin actually. Okay. degree Celsius would be in that K represents Kelvin actually. Okay, no problem. We have already talked about it. So there are different zones, and when we are talking of this, like this is 4000 K and 8000 flare. Yeah, this one, like this zone. This is called Corona. Can you read this Corona? Right?
Corona.
Yeah, this is what outer zone, the external zone, the surface zone, right?
Mm-hmm.
This is what we have read. This is how much?
Um,
It says Kelvin, 500,000, right?
500. Yes.
Thousand. But we found on Google research that gives estimated data. This says like 500. Yeah, yes, 500, 5.500 degrees Celsius, right?
Mm-hmm.
5,500 degrees Celsius, right?
Yes.
5,500 degrees Celsius. Yeah, so that is what we got here. So that varies from the layer it has. So sun may have different layers, right?
Yeah.
We discussed all the layers here. So let's go back to that which we were discussing. So now read next the repulsive force from here.
The core temperature rise. Oh no. Wait.
The repulsive force.
The repulsive force between the nucleus is
Nuclei.
over
Nuclei.
nuclei is overcome by the force of gravity, so the core compress, but the recoils and
Recoils, yeah. Hmm.
the energy of the recoil is transferred to the
Not recoin. That is recoil.
the
La.
recoil is transferred to the envelope of the star, which then explode and produce a shock wave. As the shock occurred, material
Encounters, not occur.
enc-
Encounters.
encounter
I told you
material.
the meaning of encounter. Do you remember that? Encounter
Yes.
mean. What is that?
Facing something.
Very good.
Material in the star's outer layer, the material is heated, fusing to form a new element and radioactive um,
Isotopes.
isotopes. The shock then propels the matter out into space. The material then is exploded away from the star, is now known as supernova remnant.
Hmm. So what did you understand?
Um, like
Repulsive force means attracting or distracting.
attracting.
No, it's the opposite of attraction.
Oh.
So the core compresses but then recoils. The energy of the recoil is transferred to envelope of the star, which then explodes. So it explodes. This is something like in X-rays form, Cygnus loop in X-rays, and this is in Crab Nebula in X-rays. So this is what it looks like. So a white dwarf goes thermonuclear. These are the things. We may be discussing more about it in coming classes. Let us now move to our core conceptual PPT. Okay. So I just gave you a kind of glance of something which is called supernova or which is called nebula, right?
Yes.
So now basically you have understood nebula, supernova, like nebula can be some of the dust and particles found in a space, mostly in the form of which gas?
Um,
Helium and yeah.
helium and uh
Check your notes. Check your notes.
hydrogen.
Yeah, right. So nebula can be dust particles found in a space in general way, not in sophisticated way. So that can be found in a space like dust particles and some other things. Um, Mostly helium and hydrogen. And supernova is what? Now, can you explain supernova to me?
A powerful luminous stellar explosion.
No, no, no. Just tell me in general way. Don't read that definition. Supernova comes after. When a star,
like the when the star explode.
yeah, when a star dies, when a star ends its life. And we read that how many times stars can be massive than sun? Eight times
I don't.
or more than that. 8 times or more than that. We read that on the site right now on the NASA site. Some stars are 8 times massive than sun or more than that, right?
Yes,
And when they explode, what can be the temperature of them? How much?
400 billion.
100 billion degrees Celsius. And what about the temperature of sun on its core in the center?
15 million Celsius.
15 million Celsius. And on the core, no, sorry, on the surface level, what it would be?
Um, 500. No,
No,
wait. 5
5.5 K
5.5K.
degrees Celsius. It means 5,500,
5,000
yeah,
Celsius.
degrees Celsius. Okay. Yeah, so that's what we understood. So this is the picture you may see like some of the things like temperature. This is written K. K means Kelvin. Kelvin is also a unit, measurement unit. Okay.
Uh-huh.
Yes. So number density charged particles. This is in meter cube, and we see most of the things here: nebula, and we see solar wind. We see interstellar space, auras. Auras can also be stuff. Everything can be, you know talked in detail. I have already shared this PDF of this presentation, right? You got that or not?
Um, Not sure.
Okay. All right. This PDF is sent in the WhatsApp group. You may check that. So this is plasma. All these are examples of plasma. Okay.
Okay.
Solar core and this like lightning, flames, auras, solar wind, nebula, magnetic, this like confinite fusion. All these are example of plasma. Now comes this thing. This is very interesting and more advanced. Uh, you may go through this. BEC, Bose-Einstein condensate
Bose
or
Einstein
Bose-Einstein. Yeah,
condensate. A Bose
yeah.
Einstein condensate BEC is a state of matter of a dilute
Dilute.
dilute gas of boson cooled cooled to temperature very close to absolute zero. As atom cools, they behave more like wavelet and less than particle. When cooled through that When cool enough, their wave expand and begin to overlap. This is similar to steam condensing on a lid. When it is boiled, the water clumps together to form a drop of water or condensate. The same occur with atom, only it is their wave that merge together. Bose-Einstein condensate are similar to laser light. However, instead of um, photons behaving in a uniform manner, it is the atom that exists in perfect union. Like a drop of water condensing, the low energy atom merge together to form a dense, indistinguishable lump.
Indistinguishable lump.
Indistinguishable
No,
lump.
no, no. Wait, wait, wait.
Hmm.
Indistinguishable. Indistinguishable.
Indistinguishable
Very good.
lump.
Do you know photons?
I
Photons?
don't think so. I heard of it, but I'm not sure.
I guess you need to work more on science. Yeah. I may give you options. Photons are related with what? Water, light, or clouds. Three options.
Water.
No, you may write definition for photon. A photon is the fundamental particle.
Photon is a Fun,
Fundamental particle.
mental particle.
And then write in bracket quantum. Particle in bracket you may write quantum.
What is
Quantum.
UAN
Tum.
TUM
Of bracket closed. Now write of
of
electromagnetic radiation.
electromagnetic
Magnetic
yes
radiation. Radiation.
radiation
Carrying light, comma carrying light,
light
comma radio waves,
radio wave
waves, waves, okay,
yeah
comma X-rays.
yeah
Do you know about X-rays? I hope you know this.
yes
Yeah, comma etc. etc.
etc
Acting as both a wave and particle. Acting as both,
both acting as both what
acting as both a wave and particle. A wave and a particle. A wave, wave, and a particle,
um,
particle.
particle
Write in bracket wave particle duality. Wave dash particle duality.
okay
Bracket close, comma.
yes
Having no mass or electric charge.
or electric charge
Charge, comma, and have
and
and always traveling at the speed of light.
okay
One more thing. It is by which scientist proposed this concept of a photon? Do you know that?
I
Of
don't
course.
know
So this was actually proposed by Einstein. You may write proposed by Einstein to explain. Proposed by Einstein. Do you know the spelling of Einstein?
yes
It's written out there. Proposed by Einstein to explain
yeah
the photoelectric effect. The
the
photoelectric effect.
okay
Done. The photoelectric effect done.
yes
Comma. Photons are massless.
photon
Are massless.
mass this
Massless. MASSLESS.
yeah
Energy packets. Energy packets
okay
that transmit light and the electromagnetic
the electric magnetic
force
okay
symbolized by symbolized by
by
gamma. Do you know gamma?
no.
This is the symbol of gamma, like this. Okay, let me show you so you can write perfectly. Charis, you need to learn a lot of things about science. Um, have you not taken interest earlier in science, or you have?
Like what?
Have you not taken interest in science earlier, like in a school and all? This is lowercase gamma. This one I was talking about. You may write like this, symbol
Okay.
of gamma. Done.
Yes.
It is like Y, but it is not Y. I will show you some other pictures. This is like this kind of R, something like this.
Okay.
Is it clear now?
Yes.
Okay. I was asking like, haven't you studied science like this earlier?
This term I just started lights and sound.
Mm-hmm. Okay. Because some of the basic elements you need to work on, like when you're talking about light, this is related to light actually, photons. And
Okay.
when when the concept of a photon was discovered, like this was proposed by which scientist?
Yeah.
I told you right now. It was proposed by which scientist?
Einstein.
Einstein. But earlier it was believed this is having both of the properties of waves and what have you written? Read. Waves and
Wave and particle.
particles. Yes, right. So earlier it used to be believed that photons are just waves, but then scientists, the Einstein gave concept of photon. He said no, it is behaving like both. Photons are those which behave, which does have property of waves and photons and does not contain any mass, right?
Uh-huh.
So in that case, so dilute gas of boson cooled to temperature very close to absolute zero, that can be known as Bose-Einstein condensate because it was proposed by Bose and Einstein. Basically, photon was proposed by Einstein, so it is named as Bose-Einstein condensate. This is something you may see like um, this picture you can see.
Yeah.
It shows kind of wave kind of stuff and lightning stuff that also may discover about science. You may take a snapshot of it.
Okay.
Yeah, so the five state of matter we discussed, that is now Bose-Einstein condensate, lower temperature, too lower. This is based on the temperature. Lower, and then solid, and then liquid, then gases, then plasma. But if we talk about categories on the basis of number, so solid, liquid, gas, and the fourth name is plasma, and then fifth one is
Lick
Bose-Einstein condensate.
lick
Okay,
balls.
but
Uh-huh.
on the basis of temperature, lowest temperature would be found in Bose-Einstein condensate. Okay,
Okay.
and the higher temperature would be found in
Plasma.
plasma. Very good. So this is what we had to discover together in this PPT. And there are some questions I wish you to write, and you must work upon those questions. Okay,
Okay.
so write some of the questions which I'll just letting you know. So firstly, just write hmm, what what are
What
are
are
supernova, comma nebula? What are
super
supernova, comma nebula,
nebula
and
and
um, massive explosions of star?
massive
Explosions of a star.
Shape of star.
Stars. Okay. So you need
Yes.
to work on that too. And then write, um, has any, right? Has any
Any
probe, Probe,
P R E E probe
reached sun
reach sun
yet
yet
to observe it?
to observe it.
Re- Research and collect data.
Research
And collect data.
and
Collect data.
collect
Data.
data. Okay.
Okay. So these are the things. Now I would like to show you something. Um, you may research on these questions, okay? For
Uh-huh.
sure. Um, One day I was just sitting somewhere outside. I just started observing my sky, and I just started questioning myself. Like that day, I questioned you, like why is the color of the sky blue, and some of the clouds are white, some of them are gray. Then I went in detail, and I just wondered if any probe or anything has reached the sun and it worked on monitoring it or observing it. Then there came another question in my mind. There is actually NASA's Parker Solar Probe, as you can see on the screen. Can you see that?
Yes.
Yeah. So this is NASA's Parker Solar Probe that you will be putting in your research as well, because I have given you question on the basis of that. So my mind worked on finding that how that solar probe can reach near sun and not be destroyed. Are you interested in that? Like we know like solar or sun is that much powerful that it can destroy and burn everything, right?
Mm-hmm.
Karish. Sun can burn all the devices or not?
No.
Sun cannot burn devices if you device reaches near sun.
Maybe.
What if you reach near sun? Won't you be burned?
Yes.
So devices can also be melted. So I was interested in this Parker Solar Probe, that how it works actually, why it is not being affected by sun rays, that much heated rays. Our body's temperature reaches highest, or when like what is our body's normal temperature? Do you know that?
Yeah. No, actually.
Write this question for your homework.
Okay.
What is normal temperature of our body?
Okay.
So this is Parker Solar Probe I want to show you. And this work in this way, white ceramic coating, and this actually has a cooling shield. That's why it does not get destroyed in when it is near sun. And you may also find like how this work actually. So when we are talking about it, we must also remember like this solar probe is how far probe how far from sun. So we may find like this could only reach the Parker solar probe gets incredibly close to the sun the till now, and reaching a record distance of about 3.8 million miles. It means 6.1 kilometer 1 million kilometer from the solar surface. Surface is how much heated? I told you earlier. What is the temperature of surface of the sun?
Um, 5.5 K
Yeah,
Celsius.
5,500 degrees Celsius. So it has reached 6.1 kilometers uh, far from sun, right? You know what
Mhm.
must be the temperature around in that it must be dealing with. Hmm?
Not sure.
You may research on all these things as I have given you the questions. So this is an interesting fact. Like 4,30,000 kilometer, like record speed this is going, and the to fly through the corona is the outermost layer of the sun, and collect data, getting closer than any spacecraft ever before. So this is something scientists actually developed, and this is amazingly recording all the observations from sun. Isn't it interesting?
Yes.
Yeah, so that's what we got today. So what did you learn today? You may just tell me. And which part did you enjoy? Yeah,
About
yeah,
supernova, the bhala,
yeah,
and the temperature of the sun,
yeah,
photon.
yeah.
Yeah.
Anything else?
Um, I don't think so.
Okay. So these are the things and the questions which I gave you. You will be working on that and you will be putting your research, and kindly work on the homework regularly. Do not miss any question. Okay.
Okay.
I hope you enjoyed today's session or not.
Uh huh.
Bye. Take care.